Hi, everyone. Welcome to Aura Import Anywhere, Anytime. The session is presented by Dhru Devalia and Chen. Welcome to this session. I am going to hand it over to Dhru and June now.
Hey, everyone. Hope you've been having a good Notes Day and enjoying the other presentations. Thank you for joining the session on Aura Import. So today, June and myself will be walking you through the Aura Import service. So this is a no-code solution to getting your data into Neo4j from another data source. So we want to make this, we'll do a quick demo and then just sort of go through this as quickly as possible. So quick introduction. My name is Dhru. I'm a software engineer based in London. I'm working in the connectors team for the last year and a half. Other than the Aura import service, something that my team are responsible for are the Kafka connector, Spark connector, and the Microsoft Fabric workload. And with that, I'll hand it over to Chen.
Good afternoon, good morning, and evening, everyone. My name is Jim. I have been working for Neo4j Data Importer tool for 4 years and witnessed this tool getting more and more popular from time to time. Let's get started.
So very quick agenda for a very quick meeting. So we'll talk about import today in Aura. I'll do a quick demo. I'll briefly talk about what new features will be coming soon for the Aura import service, and then we'll wrap it up with the Aura import API and CLI. So today, when you go to the Aura console and you see the import tab and the list of data sources that we have, we sort of have, I would say, 4 specific categories of data source. So one side of this would be your relational databases. So this includes Postgres, Oracle, SQL Server, MySQL, and a handful of few others. Your data warehouses. So this would be Snowflake, Databricks. You can also process local files, which can be dragged and dropped directly into Aura. But for the sake of this meeting, I'll be talking about cloud bucket storage, which is a recently added set of data sources. So we currently support the 3 major cloud providers, AWS S3, Azure Storage, and Google Cloud Storage. So in this demo, I will be doing an import from Google Cloud Storage. Just a comment, if there's a data source that you don't see that you'd really love to import from, please let us know and we'll try add it as soon as we can.
So yeah, let's get started from importing from the Google Cloud Storage. All you need is your CSV files in a specific cloud bucket. Here we take the flights dataset as an example going forward. Flights dataset records flights with corresponding departure and arrival airports, aircraft, and passenger bookings. These tables are interconnected with flight ID, airport ID, ticket ID, aircraft ID, etc., like relationship database without primary key and foreign key data. Let's see how we transform those tables into a graph. In addition, we need an associated HMAC key with valid permissions to access those files. You can either generate it from user account or service account. We will walk you through it shortly.
So, and with that, a very simple demo. So this is Aura today. Hopefully everybody can see this as it is. So step 1 is to go to the import tab. So a prerequisite for this, obviously, is that you have an instance currently running in Aura, and then you have some information that you would like to import. So if I click new data source here, we see the list of data sources that I described earlier. We're going to start with Google Cloud Storage. So this will be CSV or Parquet files that we want to import. So we're given a form and we just want to configure it. So what is the name of our data source? So we're going to be using the flights data set. So I'm just going to call this flights. So here we need to provide our bucket paths. So like Jen showed earlier, we had a list of CSV files that we wanted to import, and that's where we would put this in here. On the left-hand side here, we have a temporary table name. This is simply an alias. The reason being is that your CSV and Parquet file can include wildcards. So for example, if you had your aircraft data and split over 10 different files, assuming they were named accordingly, you could reference them using a star. And that would mean that we can import all of those files and you don't need to type in every name individually. And then the HMAC access key. So I'll just show you in the UI. This is Google Cloud Storage. This is the same data set that Jen had shown. So for example, here we have aircraft data in the CSV file. If you don't know how to get your GS util path, simply you can click 3 dots here and click copy GS util URI. So I'll go back to my config. I'll type this in. And as you can see, we have our GS prefix. This is our bucket name, and this is our CSV file. So just going back to what I mentioned before, if we, for example, had multiple aircraft data files that were named accordingly, we could do something like this, add a star, which would represent everything that has this prefix. And then we have my temporary table name. I will just call this aircraft data. And then finally, our HMAC access key. So once again, in the Google UI, this is my bucket. I'm in Google Cloud Storage. I can simply click Settings, Interoperability, and then these are the same options that Jun mentioned. So we can create HMAC keys for our service accounts, or we can create it for users. So for the sake of time, I will show a pre-configured data source that we have here. So if I open this up, this is the same flights data set. This is a list of all of our CSV files with aliases, and then my access key. The very first time that you create your data source, we will do some schema introspection. And we create a graph model from this data source. So if I show you this, this is what you will see. So as you can see, we've done some metadata extraction on each of these CSV files to receive their CSV headers and associated information. With that, I will hand over to Jun to talk about model building.
Thanks. Before you can load tables into graph database, we have to define the graph and configure how those tables are mapped into each graph entity. You can either start from scratch on Canvas or using AI to give you initial suggestions or inspirations. Here, we power up LLM to understand each table with its columns and how those tables are interconnected to generate nodes and relationships with conventional names for you. Since LLM takes a little bit of time for the reasoning, to save time, we have already prepared a previously generated graph. Let's take a closer look at it. Let's go to the flight node. We see it's mapped to flight table, and we picked up unique identifier flight ID. Unique identifier is important to be defined in data import because it not only avoids we load duplicated entities into the graph, but also allows us to create indexes under the hood that we can optimize read and write going forward. As I mentioned, those CSV files have no permit key and foreign key metadata, but our AI tool is able to give you meaningful suggestions. Let's also take a look at aircraft node. It's suggested that the aircraft code column is the unique identifier. In addition, unique identifiers are essential to tell relationships between nodes. In this case, a relationship is built by a specific flight ID and aircraft node. For example, the flight ID BA117 between London and New York City has the aircraft associated to Boeing 777. The table flights has rows with the corresponding data can be built for relationships. Also, the name is conventional, code uses aircraft. We're not going through the whole graph schema because you should be more familiar with your own data set in your use cases. But remember to review AI suggestions. Although it is powerful, it can be better with further manual adjustment if needed. Then I will hand over to Dhru to talk about how we start running import once we get the configuration ready.
Thanks, Jun. So we have our graph model here. Once we've reviewed it after the AI suggestion and we're happy with it, as you can see, we have green ticks on all of our nodes and relationships, which shows that this is a valid model. So for example, that mainly means that we have keys associated with all of the nodes and their relationships. Now we can click Run Import. So as part of run import, we can select which instance that we would want to import into. So I'm going to select this one that I already had that exists. And this is a brand new feature that is coming soon of 2 different import methods. The default method is just add data, which is our online import. This online import imports transactionally into your database in batches. And this is suited for, yes, as it says here, 100 gig of data. On the other hand, our brand new feature, bulk import, is an override method. This is, as a warning, we will stop the database and it overrides what's there. So this is not considered incremental. However, what this does do is allow us to manage much larger data sets. In the future, this will be supported for all data sources, but currently this will be for CSV and Parquet instances. So now that I've selected my instance and my data, I'm going to click Run. So when we click Run, we're sent to our import job list. So as we can see here, we have our flights data source, the instance that we'll be targeting, and we can go back to the model that we've generated and mapped from. So at a high level, we can see the status of the job. So this is currently running, and then we can see the status of previous jobs. So for example, if this job were to error, we could click on this error job, click view details, and see what the error message is. This, for example, was targeting 2 import jobs against the same Aura instance. But if we go back to the job that we've just submitted and click view details, we can now see fine-grained progress reporting for what is happening and what is being imported at this time. So as we can see, in yellow, we have our nodes, and in gray, we have our relationships. Already only a minute in, we've imported the majority of our nodes. As we can see here, this is 33,000 nodes. These are completed, and we'll be importing our relationships next. So there seems to be around 2 million relationships and approximately 1 million nodes. Just as an example, at a top level, if we want less fine-grained, we can see a percentage bar of how much of the import we have done already. And just to show you really quickly, this is what a complete import looks like. While this is still running, I'm going to go to an instance that we already have, and I'm going to run a query called schema visualization. And what this should show is these are all our nodes and relationships after the import and our graph schema, which represents the model that we've already mapped earlier. With that, I will go back to the slides and Jen will talk about Aura Import API.
So with the increase of interest, we initially provided 3 new Aura Import APIs that expand on the capabilities of import services, providing programmatic access to trigger and manage your import jobs. You can either trigger, fetch, or cancel an import job. By triggering an import job, simply in the payload, you just provide your import model ID and your target Aura DB ID, along with your Aura organization and the project ID. For more details, you can look into our documentation. Next slide, please. The Aura Import API functionality is also available directly through the Aura CLI, providing a convenient command line interface for managing your import jobs. To summarize, in this session, we have covered Cloud Bucket Import with GenAI capabilities, with a newly introduced Import Progress UI, API, and the CLI tools. We will release more exciting features like the composite key support, scaled import, etc. going forward. So please stay tuned for upcoming updates. We'll be around for the next couple of minutes for Q&A, and also welcome to contact us for any suggestions.
Yep, thank you very much, everyone.